Good afternoon. Myself Karthikeyan, Assistant Professor, Department of CSC, Government College of Engineering, Sengipati, Tanjavur. Today, I am going to discuss the concept of control flows in Java. So, whenever you are going to design whenever writing any program, there are different ways you are going to write. Means there are different possibilities we have based on our requirements. So, the first of all, we must know what are the different type of flow. There is a possibility we have in the program structure based on the suitable structure. We based on the suitable structure which is adaptable to our application, we are going to decide. So this a control flow always define the sequence of execution what we have in our program. So in Java, so there are three possible types of sequence structures we have. I can repeat once again. So there are three types of a structure. That is a control flow can be supported by a Java. One is a sequence structure. Second one is a branching or selection structure. Third one is a looping or iterative structure. So if we say it is a sequence structure, it means that the sequence or the statements in the program, or maybe the statements in the function definitions are executed one by one without skipping the any codes. So this is called as a sequence structure. So the statements are executed without skipping any statements in a program, then it is called as a sequence structure. So normally this is a sequence structure will be suitable. And the suitable application is if you are having any formula, if you are going to implement the formula for any calculation, we can go with the suitable structure. So that means we can go with the sequence structure. I can repeat once again. So sequence structure, there are three types of structures supported by a Java. One is a sequence structure, second one is a branching, and third one is a looping structure. For the selection structure, sequence structure, if you are saying the structure is a sequence, all the statements in the function body will be executed when structure. So normally this sequence structure is adopted or suitable for the application which contains those kind of application. So let us take, I written a program to implementing the concept of bitwise operators. So here we have a declaration part, so then followed by the calculation along with your printing part. So here, all the statements in a program will be executed one by one. So we know that the program execution from top to bottom, and the execution always starts from a main function. So while executing it from the function, while start to execute from the function, there's a declaration part will work. Then after the declaration, the first printf statement will work for execution of a bitwise AND operator, then followed by bitwise OR operator, then followed by XOR operator, then a ones complement, right shifting and left shifting operator. So in this order, the program execution will take place. So here I'm going to compile it. Just I'm going to showcase how the program execution takes place. So now I compile the code. So I hope that it's no error. So that once there is no error, then automatically the dark class file will be created for that class is called operators. Then after that, then after the execution is over, so then we are going to run it. So while running a program, so each and every line will be executed and it can be executed only once. So it is called as a sequence structure. I can repeat once again about sequence structure. That each and every statements in a program will be executed one by one without skipping any statement, and each and every statement can be executed only once. Then it is called a sequence structure. So normally this sequence structure is suitable only when that application contains the formula to implement. Next one, it is a looping structure. So we can't say that for all kind of a concept, we can, all the statements in the program may be executed. In some kind of a situation, so maybe we expect that some kind of a statements need to be executed and only once. Okay, let us simple example. I'm going to select, assume that you are going to apply for a Anna University counseling. So after apply, then we need to select a college. So our procedure is we need to select a college and we need to select only one department in our degree. So there are different possibilities we have, like we have a computer science department, we have mechanical, civil engineering, electronics and communication engineering, electrical and electronics engineering, mechatronics, even for food technology, there are different kind of department we have. But here, out of these choices, we are going to select only one choices and it can be made only one time. So that is called branching statement. So we have a set of operations, set of statements we have. So from out of the set of statement, we need to select only the few kind. We can go with the branching statement. So if the one select only set of statements which can be executed only once, and the remaining set of statement at the remaining cases will not be executed. Then this type of selection structure is called as a branching or selection structure. Okay, and another one more example for easy to understand. I'm going to check whether the given number is a positive or negative. So there are two possibilities I have. Either the number is a positive or maybe the number is a negative. So in this case, if the number is a positive, then you can't say the number is a negative. You can't take any action for a negative part. So only for the action we want to take whether what the action we want to perform, only those operations need to be carried out, but the remaining the negative part operations will not be take care of it. So this is called branching statement. So normally there are different kind of a branching statement will be supported by Java. One is a simple if, second one is if else ladder. If else, then third one is if else ladder. Third one is if ladder. Then fourth one is nested if. And fifth one is switch case. Okay, so for a simple if, so normally for this is a decision, and also we call as a decision making statement. Also this a control flow depends on decision making. It is a very, very important. The control flow also depends on decision making process. So clear? So decision making, so that this branching and looping is coming under decision making structures. So here for decision making, we need to test the condition. So the syntax for a simple if is so if always we need to write a condition. So if the condition is true, then the set of statements in this case will be executed. So we call as for a easy understanding, we call as true actions, or maybe we call as a true statements. Clear? And we know that each and every statement in Java can be terminated with a semicolon. Okay, but here another very, very important. So for a branching statement, means a branching statement will not be, the condition part will not be terminated with a semicolon. So for easy remembering, I will give you one shortcut idea. So if that statement means if you are going to make a block of statement with the help of this curly brace, the previous statement of this open curly brace will not be terminated with a semicolon. So this is the easy way to understand. And the next one is if else ladder, and the thing is the simplest will be suitable. So when the application contains only one choice, only one possible choice, then we can go with simple if. So for simple if, I'm going to say that I'm going to find that for example, for checking for a simple if, I'm going to say how one simple example is find the absolute value of the given number. Absolute value of a given number. It means that if the number is negative, then this convert into positive number. That means absolute value means the number always should be in a positive number, so that only one action we have. If the number is a negative, then we need to convert the negative number into the positive number. Okay, let us take examples. So I'm going to take only one number as an input. You can take any case. For example, I'm going to take my number is 34 minus 34. So here I'm going to check in. So if condition, and condition always to be expressed with the help of relational operator, so that a less than 0. So then we need to convert into a equal to a into -1. So I'm going to converted this negative number into positive number. Then system.out.println. So absolute value equal to, then the value is a. So now the program is saved. So now I'm going to compile my code. So then I'm going to run my program. Absolute value is 34. So in this case, and another important thing, here I didn't mention a curly brace. Normally the branching statements have a group of statements, so that it will be grouped with the help of curly braces. So if your actions, or the means that the part of the true statement contains only one statement, then the curly braces are optional. Okay, so this is the way we are going to implement the concept of a simple if statement. So this is a similar to, this is all branching statement in Java. This is similar to C and C++. That is two changes on it. And for if else if, so the corresponding if else if is suitable. Exactly, we have possible cases. Exactly, to have two possible cases. So the syntax is if, syntax is condition is, so if condition, so if the condition takes are true statements, we simply call as a true statements, or maybe as an action. Positive statement also we call as a positive statement, else always indicated it is a negative statement. So again, there is a similar, if the either true statement or false statements are a single line as an action, then it will no need to group with the help of curly braces. So this is the possibility for if else. So syntax for if else. So just to take a simple example for if else case, I'm going to check it for given number is negative or not. Sorry, even or odd. Given number is even or odd. So I'm going to write a program for this. So I'm going to take a one number as an input. There are two possibilities. So the action is, so system.out.println. So in if case, I'm interested to go with the odd number. So based on our expectation, we can define it. So here I'm expecting that in if cases, I'm going to take an action for odd number. So in this case, I'm going to define an even number. So only one action, so that the curly brace is optional, as we mentioned earlier. So that we need to change the condition according to that. So for even checking for even number order, just we can divide the number by 2. So the divide by 2, if the remainder is 1, then the number is called as odd number, otherwise it is an even number. So here the working principle is, it will check the condition. So if the condition is true, then the if part will be executed. Once the if part will be executed, then the content of the else block will not be executed. If this condition is false, then go for the else block, that is called negative block. Then the content of the negative blocks will be executed. So now here I am going to run this code and test my programs. So for this program, I'm consider that the value of a equal to 10. So the remainder of this division is 0, so that it is an even number. So that in this case, the if case will not be executed. So that it go for the negative cases to execute. Okay, in case I'm going to change the number is 11. So now if we are divided with the modulo with the 2, the remainder is 1, so that the if block will be executed. Once the if case is executed, then the else block will not be executed. So it is, once again I mentioned it, it is always a similar, the concept of the if else ladder and switch case, everything is similar to the C concepts of C. Clear? Okay, so that I'm going to explain what it is. I'm not going to say any example for this. Okay, third one is called else if ladder. So normally else if ladder is suitable for when you are having more than two possibilities. More than two. So then the syntax for defining a else if ladder is, then we can go it through actions, through statements, or maybe we call as positive actions or positive statements, whatever we can call. Positive cases 1. So because we have more than two cases, so that else again if condition, this is a condition number 2. So then we can write a positive conditions, the corresponding actions. So like that, you have like as a ladder, you have to write any number of if else cases. Else cases. At the end, if you want, we can define else. But here in this case, the cases of this is optional, not necessary to define optional. That means part of our code. Clear? Okay, this is for checking else if ladder. So a simple example, we can go with grade calculation. We can go with the grade calculations. So that we have a grade like yes, A plus A, B plus B, and or A. So these are the different kind of grade we have. So that for this case, we have a 5 cases, we have 6 cases we have, so that we can go with else if ladder. And for a nested if, normally it is also having a more than means that more than one condition if you want. Means that we can divide the logical operators. If you have a logical operator in the condition, it will be separated with the help of nested if statement. But it is similar to else if ladder, and a nested if means that we are going to define one branching statement inside of another branching statement. It is called as a nested if. Nested statements. One branching statement consists of another branching statements. For example, if you have a switch case, the switch inside of switch case, we are going to write if cases. It is also a nested cases. And switch cases, it is also like as a multiple choice cases, and also similar to if else if ladder. But only the difference is in this switch case, only that equal operation will be carried out with the case number. So equal operation will be carried out. Only equal operation will be carried out with the conditions. So the syntax is, and also this is switch case will be selected if you are going to select the operation without based on means not based on your input. So on this condition, we can go with switch cases. For a switch case, the syntax is switch, and you are going to pass an expression. So normally the related expression may be an integer or maybe a character, not for string. So there are two possible data types of expression. It may be in the form of integer or maybe in the form of character, not characters. Even the floating point values or will not be accepted. And in case then this is a number, it will be an identical number. So it always represented by a number. It will not be defined by any variable name. Then you can define the corresponding actions. And at the end of each and every cases must be terminated with break. If you are forgot to specify the cases, then the next cases will be executed until it reaches the end of the switch, or maybe it reaches the next cases. Means it reaches the break statement in the case. And also if you have n number of choices, you can define n number of choices, and at the end we are going to define default case. So the default cases will be executed only if no cases will be executed, and it is not necessary to define all the cases in order. You can define the cases in any order. Even we can define the default cases at the top also. So here the case numbers should be identical. If the case numbers are same, then it shows the error messages duplicate case exists. It means that there are two cases number have a same number. And the next thing is very, very important in a switch case. We call this a menu-based design. Also, we call this a menu-based design because the selection of operation is not based on our input. So in this condition, we can go with switch case. So these are the possible branching statements we have in our programming language. Then I will move on to the third structure that is called looping or iterative structure. So in a loop, iterative means first one sequence structure. All the instructions in the code will be executed one by one without skipping anything. And for the second one, we are going to skip some of the statement, and only the part of the statement is executed only once. But in case of a looping statement, the set of statements, set of particular statements or executor 0 or 1 or more times, then we can go with the looping structure. It is also called as a iterative structure. Once, if you want to apply for the concept of looping structure, there are 3 rules is very, very important. First of all, we need to identify the loop variable. Means the loop variable means the variable which controls the execution of the loop is called as a loop variable. So that the first one is initialization. Initial value of loop variable is very, very important. Initial value of loop variable is very, very important. And second one is the condition. We have to define a proper condition for number of times execution of the loop. And the third one is the modification of loop variable, that is called the changes of loop variable. So normally if the modification is not done, not specified, means it not exists properly, then maybe the loop go with infinite execution. So there is a possibility of infinite execution is possible if the loop is not executed. I mean, if the modification part is missing, if the condition is wrong, I mean, if the condition is wrong, if you're not establishing a proper condition, there is a problem. I mean, not meeting our expected output. And same way for initialization also same thing. So initialization, if the initialization not exists, not specified. If you are not specified the initialization part, so maybe error is possible in Java. That means that here garbage value will not be accepted, so the error will not be accepted, or maybe we will not get the accepted, not meet the expected output. Not meet the expected output. So from this, what we understood is, so if you want to define any rule, I mean looping concepts in our programming language, first of all, we need to identify the one variable which controls the entire execution of the loop. So for that loop variable is called as a loop variable. So for that loop variable, we need to know what is the initial value. We need to define what is the initial value. And based on the loop variable, we are going to define the condition. And the third one is we are going to change the value of the loop variable based on our expected logics. So in a Java, there are 3 types of looping statements will be supported. One it is similar to C and C++. The first one is a while, and second one is a do while, and third one is a for. So normally the working principle of a while and a for similarly same. Only the differentiated order, it's a syntax. Normally while means that the statement inside of the while loop is 0 or more times are executed. Sometimes the statement is not executed in while loop, but in most times the statement inside of the looping statement will work. For is similar to while. Okay. So the syntax for while is, so while condition, inside of that we are going to define the set of actions, set of repeated actions, and saying it is a loop statements. Also, we need to define a modification. So sometimes our logic will not handle the modification of loop variable, so that we need to define modification of loop variable also. So, but here in this, as usual in a syntax, that the initialization of loop variable is optional. But according to the rules of loop variable, the initialization must we have to define errors. So, but this is optional, but it is not a mandatory part in a while loop. So always, means the syntax is while the condition you have to define set of action. You want to define for execute for more than one time, then you can go with the modification of loop variable. It's the same way for do while loop also. Only the small difference we have. So here in a while loop, it starts with while, but in do while, the condition must be defined only at the end. So, and it will be terminated with a semicolon. So that the execution is like this. In a while loop, the execution procedure while loop is just you can check the condition. If the condition is true, it means that if the condition is true, the part of this looping statement will execute and a modification of loop variable takes place. Once after the takes place, once it reaches the end, then again go for your condition. If the condition is false, then the control will be transferred to the end of the loop. So, but in a do while loop, always the statement will be executed from top to bottom. So that in a do while cases, the looping statement and the modification of loop will take place at least to one without checking a condition. Again, if the condition, check the condition. If the condition is true, again it will be executed from do. If the condition is false, then it will go for the next line for the further executions. Clear? So this is a syntax for while, while and do while, and for here in while and do while, initialization of loop variables and modification of loop variables is not a mandatory part. So that while applying the while applying the looping concept, I told you these are the three basic rules we need to follow for implementation, proper implementation of looping statements. So that there is a possibility of if any of the statement is missing, so that we will face some causes. In order to avoid the cases, so that everyone prefer to go with the for loop. So for here we have to define initialization. Then after initialization, then we need to define the condition. Then modification will take place. So each and every part of the three rules will be separated by semicolon. So we call as sections. Even if any one of the section is missing, then means if any one of the section is missing, no issue. Means that it makes sometimes that this is the easy way we can predict. But the working principle of for is similar to while. So the first in the for loop, the initialization of initialization statement means initialization will be executed only once. Then after that it will check the condition. After that it will check the condition. So after checking a condition, if the condition is true, then the looping statement will execute. So then after the condition, the looping statement will execute, then it reaches the end of the loop. Then it go, once it reaches the end of the curly brace, then it go for modification part. So once modification will be executed, then again it will come back to the condition. So clear? So it comes to the condition. So that the looping, again, if the condition is true, the looping statement will execute. If the condition is false, then the control will be transferred to the end, means after the next statement of your looping statement. So this is the way the looping will work. So we will discuss one simple example of our implementation of these looping statements. So assume that I am going to implement the concept of and have a one variable for implementation there. So one. So I will go with while condition. So while. So normally, please try to avoid to initialize the value in the while condition. So it will be very difficult to identify the complexity. So while I want to print up to 5. So that my print statement is, I repeated statement is system.out.println. I want to print the value of 5. So then after that, we need to identify the modification. So I'm expecting that I want to print 1, 2, 3. So that the difference is 1. So that the loop variable will be modified by 1. So now we can check the output of this program. So no errors. So it is displayed 1, 2, 3, 4, 5. In case assume that I forgot to have a proper implementation. So for example, I forgot to use this modification, the change of loop variable. I forgot to implement the means the modification of loop variable. So no errors. Compiler will not make any error messages while you are missing these 3 rules. So then I'm going to run the program so that the program runs infinitely. Yeah. Okay. So so from this we can clear that if the modification part missing, maybe your programs go for infinite execution. And also the same way. And also in the same way, if the initialization is not carried out. In a Java, it makes an error message. Or if the longer initialization will go for unexpected output. means that we are meet the customer expectation. See, that might not be initialized, so that it makes an error message. But in a C, if the it takes a garbage value, so that we are unable to get a expected output. So this is the way the while will be executed. So in a do while statement, assume that the value of I equal to 6. We will not get any output because initially the condition itself false. So for these cases, the loop statement will not be executed for minimum one time. So it is executed only for 0 time, so that we will get a blank output. Is correct? We'll get only the blank output because the looping state condition is wrong. So that for always the condition is false. So that no time means 0 times the looping statement will be executed. But I am going to convert this looping statement into do while statement. I told that the while condition must be, according to the syntax, it must be present only at the end. So I am going to define the do here. So now I am going to compile the code. So no errors. Then I am going to run my program. It will divide 6 because even though the condition is false, we know that the loop will not be executed. I told that I don't want to print a 6, I want to print only up to 5. But according to the logic of this do while, the looping statements will be executed at least once without checking the conditions. So if you want to think that the particular set of statement is executed without at least once without checking condition, we need to go with the do while loop. If you think that based on the condition, if you want to perform that operation, then we can go with while loop. Clear? And also the same way we can convert this while loop into for loop. So initialization, so initial value. So then I'm going to define the condition. The condition is I less than or equal to 5. So the modification is I equal to I plus 1. So all the modification parts will be removed. So now we are easily converted into the equivalent looping part. It will be displayed as usual. So, so this is the way we are going to define the concept of looping statements in a programming language. So according to this, the loop will be executed for this particular set of statement executed for 5 times. So from this, what we need to conclude that. So while we are going to select any kind of a structure, first of all, we need to have a proper analysis of our program. So based on that, we need to identify what type of structure is suitable. Either it is a branching, or maybe a looping, or maybe a select sequence. So normally I told that for a sequence, if you want to select the sequence structure, we are going to implement the formula, then we can go with the sequence structure. If you are going to select only the particular set of statement, and once the statement will be executed only once, we can go with the branching. Then we can go with the looping for repetitive for the set of statement for more number of times. Also here in the looping statements will be classified into 2 types based on the executions. Based on execution time, one is called counter controlled loop. It means that at the time of compilation itself, we can we can predict the number of time execution of looping execution. It is called counter controlled loop, and second one is a sentinel controlled loop. It means that unable to predict the number of times loop executions at the time of compilation. Then it is called a sentinel controlled loop. So we can't predict it. Means here there is no specific and all. So based on the looping condition, we are going to predict it. So for this case, for this example program, I know that this looping statement will be executed in case if I have a variable here. For example, I will have a say n. So the value of n is predicted only at the time of runtime, or maybe we can define like n equal to 5. So then it is called as a counter control, sentinel control loop. Means the value is, based on the value which is stored inside of the variable, then it is coming under the concept of sentinel control loop. So from this tutorial, what we understood that, so if you are going to design any application, first of all, we must have a clear understanding of the application. So based on the understanding of application, we are going to decide a corresponding program, I mean, corresponding structures.